Uniform distribution. Properties of uniform distribution. Number one, the area under the curve of a continuous probability distribution is equal to 1. Number two, there is a correspondence between area and probability. So probabilities can be found by identifying the corresponding areas in the graph using this formula for the area of a rectangle. Area is equal to height times the width. Now, a continuous random variable has a uniform distribution if its values are equally spread over the range of possible values. The graph of a uniform distribution results in a rectangular shape. Now, the graph that you see here below illustrates the properties for a uniform density distribution. And then notice the area of the rectangle in the middle is 1, and the graph is greater than or equal to 0 for all x between 0 and 5 inclusive. So here we have the area is equal to 1. We're going from 0 to 5, and it's inclusive. Now, because the area of a rectangle is height times width, and the width of the rectangle is 5, the height must be 1/5, which is equal to 0.2. How do we know that? Well, here's the following. Because the area of the rectangle is height times width, and the width, the range of the rectangle is 5, the height must be 1 over the range. Well, if you take a look here, the range goes all the way to number 5, so the range is 5. That's why we get 1 over 5, which 1 over 5 is equal to 0.2. Now notice on the graph up here that the height is 0.2. So therefore, that's how we get the height. Now, values of the random variable that are x is less than 0. So that means all the values that are over here, which is less than 0, or greater than 5 in this situation, are impossible. Thus, the equation must be 0 for x is less than 0 or greater than 5. Now, the graph of any continuous probability distribution is called a density curve. And any density curve must satisfy the requirement that the total area under the curve is exactly 1. Because the total area under any density curve is equal to 1, there is a correspondence between area and probability. The area under the graph of the density function over an interval represents the probability of observing a value of the random variable in that interval.